Okay, so good afternoon, everyone. I hope you guys can see me. Okay. Right. So today we are going to discuss about alcohol, phenols, ethers. Can you hear my voice? Yes. I don't know which school it is. Yes, Dole. Can you hear my voice? Am I audible? Yeah. Thank you. Thank you. Yes. Okay. So yes, you are from which school? Okay. Okay. Fine. Right. Whatever it may be. Right. So today we are going to discuss about alcohol, phenol, ethers. So kind of crash course we are doing it. So before going to talk about alcohol, phenol, ethers, you can clearly say that they are the substituents of the hydrocarbons. Okay, whenever you are having any hydrocarbons are there, if you replace the hydrogen with one OH group, then that is called as alcohol groups. So if you are replacing with OH in benzene, that is phenol. If you are replacing OH with respect to alkoxy group, OR is called as what? Alkoxy group. Alkoxy group. That is alkyl plus oxygen is there. So that's why OR is called as alkoxy group. Clear? So now, yeah. So in this case, we can clearly say from here, okay. Right. So now, basically what is happening here? So we are replacing the OH group with the hydrogens. Now, why we need to study about the alcohol phenol ethers? Because there are wide variety of operations are there in anesthesia before the operation, the newspapers, the paper which we are reading because of the alcohol group only. Check whatever the currency notes and highly important applications are there. So for our examination point of view, we don't go much about it, but all we need to do is we need to know the classification of alcohols. So how do you classify the alcohols? That is one of the important point here. So whenever you are classifying the alcohols, we need to see the number of OH groups are attached. Based upon the number of OH groups attached, we can, if single OH is attached monohydric, 2 OH dihydric, 3 हो गया तो trihydric and 3 से ज्यादा होगा तो polyhydric. You can also call trihydric as polyhydric. So we can, you can see here CH2 C2H5OH ethanol, and we can also call it as ethane alcohol. So ethanol is the IUPAC name and ethyl alcohol is the common name. Okay, ethanol is the IUPAC name and ethyl alcohol is a common name. Whereas if two OH are attached on the adjacent carbon groups, we call them as vicinal dihalides. So these vicinal dihalides are also called as ethylene glycol. So ethylene glycol is a common name actually. So ethylene glycol is a common name, but IUPAC name one. If you are trying to give the IUPAC name 1,2, okay, diol. That is ethane 1,2 diol. You are going to call this is called as ethane 1,2 diol. Okay, right. So ethane 1,2 diol. This is the IUPAC name of this. Glycerol we usually often use in the soap, glycerin soap. So glycerol, whereas you can clearly say from the glycerol. Okay, so glycerol is optically inactive. Glycerol is optically inactive because CH2OH, CH2OH is same group attached. So this is also trihydric, 3 OHC attached. Now sorbitol in JE mains, the question asked about what about sorbitol. So sorbitol, they asked the question. So the sorbitol is basically optically active or inactive. They are asking, is there any meso compounds are forming or not, or optically active or not? They are asking. So if you see this carbon, so it is attached with one hydrogen and one OH group and one this group, particular OH group. So yes, this particular carbon is attached with OH and H. Yeah, another H. So this is not a steric center. But whereas if you see for this one, 1, 2, and another one, 3, and the fourth, 4. So this is a steric hydrogen, sorry, steric carbon. Whereas if you see, this is one type of arrangement. Let me erase this one. So we got to know, so this is the sterocarbon, and here you can see this is one arrangement. So this is one arrangement, and this is another arrangement. And here one hydrogen will be there. Okay, and here OH is there. So this is also another stereo center. And whereas if you see this one, this is another hydrogen. So this is also another stereo center. So here also, this is also another stereo center. So total, how many sterocarbons are there? 4 sterocarbons are there. So 4 sterocarbons are there. So these 4 stereo is optically active, and they will give how many isomers? 2 to the power of 4. So that is 16 isomers it can give. Optical isomers it can give the 16. Okay. So that is very, very most important for your examination. How many stereo centers are there for this orbital? Like those kind of questions may also ask. Moving forward, so how do you name the compounds, and what are the, based upon the classification of alcohols, based upon the number of carbons it is attached. So monohydric, if you see, if it is attached to sp3 carbon, how we are going to name? If it is attached to sp3 carbon, how we are going to name it? We are going to see. Alkyls can be primary, secondary, and tertiary. Allylic is basically sp2 bonded sp3 carbon, which is bonded with OH. So this is usually called as allylic group. Benzylic, where you are having benzene and CH2OH. So these particular groups are called as benzylic alcohol. Benzylic alcohol groups are there. We are going to call them as benzylic alcohol. And whereas sp2OH groups are simply nothing but directly OH is attached to the sp2 carbon. I hope everyone understand this one. Clear? So next, moving on. First one, alkyl halides. How do you differentiate the alkyl halides? Simply, we know that if number of attached carbons. So this carbon is attached with alcohol group. So this is our main alcohol group. So like this is the carbon. This is the carbon where OH group is attached. Okay. So but this carbon is attached to how many carbons? Only one carbon. So then this is primary. And if you see this particular carbon, this is attached with OH. So this is attached with 1 and 2. So this is secondary. And here it is attached with 1, 2, 3. So that's why tertiary. So this is sp3 carbon, which is attached with different carbons. We can call them as primary, secondary, and tertiary. Okay, so classification done based upon the number of carbons attached to it. Next, allylic. Allylic carbon is simply nothing but it is attached to the sp3 hybridized carbon and adjacent to the carbon-carbon double bond. So you can see here OH is attached to the sp3 hybridized carbon, and this sp3 hybridized carbon is attached to the double bond. Double bond. So this is called as allylic alcohol. What you are going to call it as? Allylic alcohol. And this OH is attached to this carbon, but this carbon is attached with only one carbon. So this is also called as primary alcohol. So allylic में primary alcohol. Okay, allylic में primary alcohol. And in allylic secondary alcohol, how it will be? Same. Replace one hydrogen with OH groups. Yeah. So just a minute, guys. Yeah. So replace OH, replace hydrogen with one methyl group. So then this will become secondary. Simultaneously, tertiary also you can easily find. Tertiary means replace all the hydrogens with CH3 groups. Then this is tertiary. So in case if you are having here, methyl group is there here. In case if I am keeping ethyl here, in case if I am keeping ethyl here, then this is called as stereoisomer. Then this is called as stereoisomer, or you are going to get a stereo center over there. I hope you guys understand how do you classify the compounds based upon the number of carbons attached to it. Next, simultaneously benzylic. What is benzylic? Benzylic is nothing but OH is attached to sp3 carbon, and that carbon is attached to the aromatic ring. So primary, secondary also we are going to have. Same. same story. Here, this carbon is attached with only one carbon, and replace the hydrogen with CH3 group. Here, one C carbon is there, so that's why secondary. Here, two carbons are there, so 1, 2, 3 are there, so that's why it is tertiary. So I hope you understand how do you classify. Okay, how do you classify the alcohol groups? Okay, next, classification of phenols. How do you classification of phenols? Simultaneously, where we have seen, okay, phenol classification, that is very most important. Okay, so phenol is simply nothing but it is a substituted group. OH is substituted on benzene. That's we call it as phenol. And catechol is also called as dihydric alcohol, where phenol is substituted with ardo, or we can also call it as ardo. Phenol, we can also call it as, and this is a resorcinol, and this is quinol or quinoline, hydroxyquinone. We can also call it as 1,4 hydroxy, sorry, 1, 2, 3, 4, 4 hydroxyphenol. You can also call 3-hydroxyphenol or 2-hydroxyphenol. And simultaneously, you are having arthocresol. Okay, so cresol is also there. So try to see the NCERT ones. And very most important, pyrogallar and fluoroglycinol. So these are out of NCERT, but still you can see these questions. Okay, yeah. So JNV Tapi team, they have joined. So classification of phenols is also done. Next, how do you classify ethers? So simple, there are two types of ethers are there: symmetrical, simple ethers, mixed or unsymmetrical ethers. Just you can see here, dimethyl ether. Dimethyl ether means you are attached with CH3 group on both sides of oxygen. And you can see diphenyl ether. Two phenyl groups are attached to the oxygen. Next one, mixed or unsymmetrical. Alkyl or aryl groups attached to the oxygen atom are different. Okay. Now you can see ethyl, methyl ether, ethyl and methyl ether. So here the number of carbons attached adjacent and the alternate oxygens are different. Here we are having one carbon, here we are having two. So these are unsymmetrical ethers. Okay, this is also called as ethyl methyl ether or ethoxymethane. Okay. Phenyl methyl ether, where phenyl and methyl is attached to on the both sides of oxygen. Now, classify whether they are primary, secondary, and tertiary. So I'm giving you 2 minutes of time to whether to find which is primary, which is secondary, and which is tertiary. Take 2 minutes of time and try to answer this. Okay, last minute. Last 10 seconds. 5 seconds. Last. Done. So now we have got to know from here. We have got to know. Yeah. So from here, the whether it is primary, secondary, or tertiary, it is attached with the alcohol containing carbon. How many carbons it is attached? So this is attached with only one. So that's why this is primary, and this is attached with 1 and 2, and this is secondary, and it is attached with 1, 2, 3. So that's why it is tertiary. And if you see 1 and 2, so that's why it is secondary. So it's about the OH group which is attached to the carbon, and it should be like that. And now they may ask about these three, which is allylic one. So here you are having double bond sp2, and this is sp3 carbon. So this is allylic. Okay, so this is allylic. And what about this one? This is okay. So this is called as benzylic. Benzylic secondary alcohol. Okay, and this is also benzylic. Benzylic. Okay, secondary alcohol. Okay, I hope you guys are clear with this, right? Now we just want to see the primary, secondary, and tertiary. This is also second. Nomenclature of alcohol. So we basically call them as, methyl alcohol, ethyl alcohol, and isopropyl alcohol. Commonly we can call them as, and pentyl alcohol. Pentyl alcohol also we are going to call them. And if you see, these are the common names of here is neopentyl carbonyl, neopentyl alcohol, and there are some compounds where you can see secondary alkyl groups. Secondary alkyl groups will also be present in the nomenclature of alcohols. Okay, so you can understand secondary alcohols can be remembered as, okay, chemistry can be remembered as eating me. Eating me means methyl and eat means ethyl. So methyl and ethyl are attached to sideways of the carbon and which is attached with the alcohol. So this group is called as what? This is called as secondary butyl group. Okay, you ideally they are optically active hota hai. We'll see those cases in the later part. So now this is secondary. Okay, we just discussed. And whenever we are naming the compounds, how do you do? We just simply need to remove the alkane and write as OL whole. Okay, JNV Mahe, JNV Rajkot joined late. What happened? What happened, guys? Why you guys joined late? Yeah. Okay, whatever it may be. So now coming here. So in this case, how do you name this one IUPAC? Okay, Rajkot, fine. So methanol, if you see, methanol means one carbon is there. So that's why meth is root word. And alkane mein an is simply nothing but suffix. Okay, and OL is secondary suffix. OL is secondary suffix. And this is ethanol. Very good, Mahe. No problem, no problem. Try to get the YouTube link. So ethanol means two carbons are there, and simultaneously propanol, pentanol, 2 gamma 2 di. I think you people know how do you name these kind of elements, where the hydroxy group is given as first priority because it's a functional group. So functional group priority order you people need to know. Okay, my question is, can anyone tell me what is the functional group priority between OH and aldehyde and ketone? Can anyone tell me what is the preference of, very good JNV Silvasa, what is the preference of alcohol, aldehyde and ketone? Who will come first? Tell me in the chat box. Everybody, I request, please tell me in the chat box. What is the preferential order as per the UPSC? Alcohol, aldehyde and ketones. Tell me. What is the IUPAC name ordering? Come on. Okay. I am getting the responses. We'll see. I am giving another minute. I am getting responses. Okay. Very good. Yes, alcohol, aldehyde, ketone. Are you sure? I feel aldehyde will come first, ketone, then alcohol. Sure. First aldehyde, then ketone, and then the last alcohol. So homework to you guys today is try to see the functional group priority order. Okay, so functional to priority order. Everyone remember functional group priority order while naming the USC compounds is must. Okay, and this is 1-phenyl ethanol group. Next nomenclature you can see here. So pentane 2,3 diol. How do you name this one? Again, cyclohexanol. And how do you name this one? This can be explained by 1, 2, 3, 4. Okay, so that is 3-chloro 2,3 dimethyl pentane. 2,3 dimethyl pentane, 2,4-chloro, 2,3 dimethyl pentane. Yeah, so this is JEE and NEET question, JEE mains and NEET question. Try to answer in the chat box, guys. Try to answer in the chat box, giving you 1 minute time. Come on, try to answer. Okay, what is the answer for this? Anyone having any idea? Very good, very good. So one, you give number 1 and 2. So then we can clearly call it as 2-methyl cyclopentanol. 2-methyl cyclopentanol is the correct answer. Okay, 2-methyl cyclopentanol is the correct answer. Very good team. You guys are really doing good job. Next, how do you pronounce the nomenclature of phenols? I told you. So whenever the benzene substituted with hydroxy group, then we call them as cresol. So I told you in the previous, that is homework. See where there is a cresol and how do you find the catcall? Okay, all these things are very most important. Okay, these are the common terminology people need to know. Cresol means where the hydroxy group is substituted on the any toluene group. Okay, so that is cresol. Okay, next meta isomer means this is ortho, this is meta, and this is para. Okay, so now in this case, if you see the both of the oxygens, catechol, resorcinol, and quinoline. Quinol. Okay, quinoline nahi, quinol. So these are some of the important common names for that one. But what about IUPAC name? This is phenol, and this is 2-methyl heptyl phenol, and this is 3-methyl heptyl phenol, and this is 4-methyl heptyl phenol, and this is 2 comma benzene 2 comma 1 comma 2 diol, and you can easily say 1 comma 3 diol. So okay, very most important thing is you people need to know how to write the IUPAC name. So try to make it, note down of it, giving you 1 minute of time. Try to make down of it. Okay, so that is another important thing. Next, if you see common names for the ethers: dimethyl ether, ethyl methyl ether, methyl phenyl ether, or we can also call it as anisole, ethyl phenyl ether. So now how the IUPAC again phenyl ether or diphenyl ether. So yeah, these are the some common names. How do you see in this case is like this group, if you observe, this looks like a isopropyl group. This looks like a isopropyl. Isopropyl is strictly nothing but CH2, CH3 and CH3. So this is isopropyl group. So isopropyl and methyl is attached. So that's why methyl isopropyl ether. And next one is phenyl propyl ether. Okay, I hope you guys understand how do you naming the common names of ether. Now IUPAC name of ether is here smaller the R plus oxygen plus bigger alkane chain. So based upon this rule you have to go. Smaller R, that is alcohol should be small, or the alkyl group should be small. AR means aromatic plus oxy plus bigger alkyl chain also. Bigger alkyl chain होना चाहिए. So now if you want to name this one, this is symmetrical one, so then no doubt methoxy benzene. This is called as, sorry, not methoxy methane, not benzene, methoxy methane. So here methane is on the sidewise side are same, so that's why methoxy methane. And next one, if you see methoxy ethane, so now this is becoming the main chain and this will become the substituent, so that's why we are going to call them as methoxy ethane. Next, in this case, if you see there is a phenyl group is attached, and there is CH3. Obviously, phenyl will given by the priority of benzene. So we can clearly say methoxybenzene, methoxybenzene, and anisole, next ethoxybenzene, right? We can't see much difference in the IUPAC name. Try to answer this one. Whatever this one, what is the product? Like product, like if you see in this case, how do you answer this one? How do you answer this? Very, very important question. If you give number 1 here, number 2 here, how do you answer this? Take 1 minute of time and try to answer this question. IUPAC name. Okay, 1 minute time lo or start karo. Okay, so the time is up. I don't think so. None of them has given answer. I don't know what is the problem. So if you given here, so this is called as what? 2-methoxy 1,1 dimethyl cyclohexane. Why they have given this one? Very, very most important. Let me take. So in this case, why one number is attained to this carbon is, if you see CC, if it is 1 and OR is at 2, so 1 plus 1 plus 2 is equal to 4. So the 1 plus 1 plus 2 is equal to 4. This is lowest IUPAC number. But if you give 2 to here, then 2 plus 2 plus 1. So this will be what? 5. This is the lower number. So lowest priority functional group or lowest group order. So we are going to get this particular IUPAC name. So that is 2-methoxy 1,1 dimethyl cyclohexane. And next, so try to answer this IUPAC naming, at least 1 or 2. Let's suppose A, B, C, and D. So try to solve A, B, C, D. I'll just come. Okay, just try to solve A, B, C, D. I'll just come. Is there any answers we got? Any answers? Yeah, I am getting answers. Very good. So we can see each and every answer now. So this one, based upon the priority of functional group, we need to give the number 1 and 2 should be adjacent for the double bond. Now this is called as hexane 3-ol, and here it's very answer is came hexane 3-ol. Very good, very good, very good. So what about the answer? This one, 2-bromo. Yeah, correct. 2-bromo butene. Okay, but 2 in 1-ol. Methyl 3-methyl 2-bromo 3-methyl but 2 in 1-ol. But 2-bromo 3-methyl but 2 in 1-ol. I hope you guys understand. So simultaneously, these are some of the examples. Please kindly do it and don't forget. ये very most important है JEE mains के लिए. इसको NEET के लिए भी बहुत ज़्यादा important है. Last question. So try to solve and come before you doing the questions. Okay. Next one, how do you define the structure of alcohols? So they are usually sp3 hybridized. The carbon is sp3, oxygen is sp3. Okay. So when there are sp3 hybridization, the bond angle is less than tetrahedral, and due to this, the repulsion between the unshared electron pairs are formed. तो यहाँ पर क्या हो जाएगा कि because of the presence of more electronegative, okay, the bond angle कितना होना चाहिए? 109 degrees 24 minutes होना चाहिए if it is sp3 means. So for sp3 the bond angle should be 109 degrees 28 minutes, but it has reduced to 108. So हमको ये लगता है कि बहुत ही कम ही difference है, but this is the reason, means repulsion between the unshared electrons and oxygens are the reasons because of the less or limited bond angle with respect to the over one. Okay. Next, structure of phenol you can see. So this is about the structure of phenol. OH group attached to the sp2 hydrolyzed carbon, CO bond length in phenol and CO bond length in methanol. Okay, so methanols are usually higher because of partially double bond character. They will generate a partial double bond character, so that's why they're higher. So what is the structure of ether? So this is how the structure of ether looks like. Okay, so try to solve this question. Try to solve. Why does the CO bond length is phenol smaller than that of the CO bond length in methanol? Try to answer. This is NCERT one. 2 minutes time. Try to answer. What is the reason, guys? Tell me. Yeah. So the reason is, yeah, very good. It will because the reason of resonance and the partial double bond character will be developed there. Very good. Very good. JNV Mahe team. Okay. So now the partial double bond character on the conjugation of unsaid electron pair of oxygen with an atomic ring. Okay. So this is the conjugation takes place. So this is what the summary we have learned till now. Okay. So how do you name the alcohols? How do you name the phenols and ethers? Okay. What is vinylic acids? Vinylic acid means where pH is directly, where OH is directly attached to the sp2 carbon, where OH is attached to the sp2 carbon, and that is vinylic alcohol. Okay. Right. Now preparation of alcohol. So how do you prepare the alcohols? So the preparation of alcohols can be done in 2 ways: acid catalyzed hydration and hydroboration oxidation. There is another one, oxymercuration, demercuration also. We'll study that one in the upcoming class. But these are the two ideal parameters which are used for the preparation of alcohols and alkenes. So let's suppose see first one we are going to see the acid catalyzed reaction, hydration. Okay. So where alkene plus water become acid catalyzed and they are trying to become alcohol. Usually symmetrical alkene, so no problem. If you are having HCl, okay, then directly add. Unsymmetrical means where you will have a double bond with two different groups attaching to it. Here hydrogens are there, but here methyl group is there. So that's why there is a difference between them. So that's why these are unsymmetrical alkenes. So in unsymmetrical alkene, how do you see the mechanism here? So it's very simple. Very simple is nothing but formation of carbocation is takes place. Very, very most important. Whenever there is a formation of carbocation is taking place, I told you yesterday, rearrangement can be takes place. Rearrangement can also be takes place. Okay, so that's what I can say from the acid catalyzed reaction. Okay, mechanism means what? Mechanism. Electrophile will be attacking the H2O and it will become H3O plus hydronium ion. And this is electrophile and this hydronium ion will go and attach on the carbon, which lead to the formation of a carbocation. So this carbocation can undergo rearrangement to attain the stability. So that's why we people need to look on it. So now what is the mechanism of step 2 is now the neutral nucleophile will attack and from there it will remove H2 OH from there as a H2 H3O plus. So this is alcohol. So the preparation of alcohol is first will be, what is the first step? The first step will be protonation of alkene to form a carbocation by the electrophilic attack of H3O plus. First is protonation and second one is nucleophilic attack and third one is deprotonation. Okay, so this is what first protonation of alkene and last one is deprotonation. So like this if we are going to do, then it will be easy for us to remember. Okay, by ardoboro oxidation, very simple. This is actually anti-Markovnikov rule, or we can also call it as Karash effect. Don't need to like worry about these kind of equations. यहाँ HB BH2 है, sir diborin H2O2O इस तरह का है, तो आप लोग जस्ट माइंड में याद रखना Marconi-Kauf rule. So what Marconi-Kauf rule will tell? The number of the hydrogen which is present, okay, the hydrogen which is present as a alpha center. Well, let's suppose यहाँ पर इन दोनों के देखो, यहाँ पर एक ही हाइड्रोजन प्रेजेंट है, यहाँ पे 2 हाइड्रोजन प्रेजेंट है. So Marconi-Kauf rule is saying that if you are having any halogen or any particular compound, if you are going for making a bond, this will become H plus and this will become H minus. So the H plus will go to the more numbered carbon with hydrogen. So जहां पर भी कार्बन के पास ज्यादा हाइड्रोजन है, वहां हाइड्रोजन जाएगा, जहां हाइड्रोजन कम है, वहां this another group will go. Okay, so OH group will join there. So usually this is prepared by the alcohol. Okay, sorry, what is alkene? So that's why. Yeah. So this is electron deficient species, and this electron deficient species want electron. So that's why it is approaching near the alkene, where the electron rich pike load has been transferred to boron. So now, like this mechanism will take place. Ultimate, you people just need to remember nothing shit is required. Okay, nothing shit is required. Hydroboration, oxidation. Okay, so hydroboration oxidation will help in the formation of the product by using the anti-Marconi-Kauf rule. So anti-Marconi-Kauf rule use करके hydroboration oxidation का question कर रहे हैं हम, ठीक है ना? I hope you guys understand. So try to answer this question. Yes, so this is hydroboration oxidation. This will undergo anti-Marconi-Kauf rule. So what is anti-Marconi-Kauf rule? H plus will go to the less numbered hydrogen contained carbon. Hydrogen contained carbon. Okay, H plus is will going to attack the less number hydrogen contained carbon. यहाँ पर देखो एक ही हाइड्रोजन है और यहाँ पर एक ही हाइड्रोजन. Okay, 1 2 3. Okay, 4. Okay, यहाँ पर तो देखो एक ही हाइड्रोजन है. So but the point here is like here you are having methyl group and here you are having only one hydrogen. So now first of all the hydrogen will go near the methyl group. Yes, so then you are going to get BH2 and repeatedly you are going to get what? Product. So the ultimate is like 3 moles of the product you are going to get from the what you are going to get hydroboration oxidation. So OH will attack on the more number of hydrogen contained carbon and hydrogen will attack on the less number hydrogen contained carbon in anti-Marconi-Kauf rule in the presence of peroxides. I hope you guys understand. Okay, yeah. So that's it about this preparation from acid catalytic reaction. And how do you prepare by the reduction of aldehydes and ketones? We are using some reducing agents here. तो आपका टेक्स्ट बुक में आप लोग देखे होंगे LiLH4 and NaBH4. So these are the some reducing agents which will help the aldehydes to get ketones. So just remember this one. This is ketone, right? So if you are giving any reducing agent, it will become secondary alcohol. It will become what? Secondary alcohol. And if you are giving any reducing agent for the aldehyde, अगर आप लोग aldehyde को कर रहे हैं, so here you are going to get a primary alcohol. Here you are going to get primary alcohol. So for secondary group, that is for ketones, you are getting secondary alcohol, and for the aldehyde, you are getting primary alcohol. Okay, so that's what not a big deal. You people can easily remember that one. Okay, yeah. So next, now we can reduce from carboxylic acids and esters. So you can also prepare from carboxylic acids and esters. We'll see that one in esterification and then by what you call reduction. Okay. Yeah, so how we are going to reduce our reduction of aldehydes and ketones will help in the preparation of alcohols. Now aldehydes and ketones, if you add any reducing agent, so primary alcohol, okay, so because this is aldehyde group, primary alcohol, and this is secondary group, and what are reducing agents? Hydrogen in the presence of nickel, platinum, palladium, okay, and LiLH4 and NaBH4. These are the some of the reducing agent which will reduce ketones to alcohols or aldehydes to alcohols. So now they strictly follow this. These are the reducing agents. Now first one, reduction by H2 or N2. If you see, then you are going to get a chiral carbon here. So this is a chiral carbon. So this is chiral carbon, and nickel and platinum palladium, what is a catalyst, is also used here. Okay. So then next, if you see, if you are using keto group, okay, this is, I already told you, aldehyde with a reducing agent will get a primary alcohol. If you see the ketone will always give what? Secondary alcohol. But these, why these nickel, palladium, and platinum catalysts are using? They are acting as a surface for the for the increase in the rate of a reaction. So that is why ketone gives secondary alcohol and aldehyde will give primary alcohol. So some of the features are this. Okay, so you can also see this reducing agent can also, like H2 in the presence of palladium and platinum, is also used to reduce double bond aldehydes, ketones, thionyl chlorides, and esters. So you can also imagine what is the power of reducing agent. Usually hydrogen in the presence of nickel, platinum, or palladium, they will act as strong reducing agents. They can reduce double bond also. I'll show you example. Let's suppose if you are having a compound like this, CH3, CH double bond, CH bond, CH2, C double bond OH. So if you are using hydrogen in the presence of platinum or palladium, what will going to happen means, so as this is a primary alcohol, our first job will be what? CH2OH will be comes first, and then CH2, and then CH. यहाँ जो double bond है, this double bond will also be undergo hydration. That is, they are going to add the hydrogen to it. And next, we can clearly say from this, so H2 is a strongest reducing agent, which will help in reducing the double bonds or triple bonds, or alkyl chlorides, or esters also. Okay, this is another important story regarding the H2. Okay, yeah, just a minute, guys. Now, if you can see the reaction with respect to lithium aluminum hydride. So lithium aluminum hydride with respect to aldehyde, same again, same story. You'll get primary alcohol, but followed by the hydrolysis. वहां पर hydrolysis नहीं है, लेकिन यहाँ हमको hydrolysis करना पड़ेगा. Same secondary alcohol. They can't reduce aldehyde and ketones. मतलब the main drawback about this one is they can reduce only aldehyde, ketone, and carboxylic acid. They can't reduce unsaturated double bonds or triple bonds. They can only reduce ketones and carboxylic acid, and they are highly sensitive towards the moisture. So they have to keep the dry atmosphere in order to avoid the moisture, that's why we are using ether there. Ether is used for the purpose of to sensitize the moisture. Okay, so limiting is an expensive reagent, so that's why people are not ideally use the lithium aluminum hydride. So now next, sodium borohydride. Again, this is another reduction A1 and reducing agent, where in the place of NaBH4 you are going to get primary alcohol. Same story, ketone you are getting secondary alcohol. It is more than selective to LiAlH4. It is more than selective to LiAlH4. That's we'll know in the upcoming class. So NaBH4 is usually have smaller in size compared to aluminum, so then it will have more affinity to act as a strongest reducing agent. Okay, na? So they can't reduce C double bond C, and other functional groups also remain unaffected. So very, very most important. So that is, we need to remember that hydrogen in the presence of any catalyst is acting as the strongest reducing agent, whereas lithium aluminum hydride and boron aluminum hydride are simply unable to react with the double bonds carbon. They can only react with aldehydes and ketones, right? So now if you see the lithium aluminum hydride, the story is remain same, acid to primary alcohol and ester to also alcohol you can get. Okay, now, so esterification. What is esterification? Esterification is simply nothing but addition of alcohols which leads to the formation of ester. So यहाँ जैसे हम OH के साथ react किए, we are going to get an ester here. From this ester, we can also use the catalyst H2 in the presence of catalyst, or PCC, pyridinium dichlorochromate. Then pyridine. These are the oxidizing agents, right? So NaBH4 or LiAlH4. These are strongest reducing agents, they can help in reducing the acids or esters. So, okay, first we have to do esterification, and then we have to add any kind of reagent which will help in the formation of OH groups. Okay, I hope you guys understand. Remember here, ester के पास एक oxygen और एक alkoxy group है. Alkoxy is completely covered to OH, and C double bonds O is also conquered as OH group. So that's why strongest reducing agent will do this kind of reaction. Okay, yeah, right. So try to answer this question. Try to answer this question, guys. This question का answer करो. What is the IUPAC name of A and B? After doing this question, I want you to answer what is the IUPAC name of this compound. Come on, guys. Try to answer this question. H2 in the presence of but whereas reduce the unsaturated bonds. Okay, take your time and answer this. What is the answer for this one? What is the component? What is the component A? Can anyone tell in the answer? Come on, guys. Please do respond. What is the product of this? Come on, JNV Mahe team and any other school, please do respond. I will write like this. So now I'll write like this: CH3, CH3, CH double bond, CH, C double bond O, H. So here we are having lithium aluminum hydride. So in this case, what is happening here? So these double bonded carbons are simply, cannot be reduced by lithium aluminum hydride. They can only reduce aldehydes and they can only reduce ketones. They can't reduce the double bond. So whatever the product you are getting, that double bond will be remain same. CH3, CH, double bond CH, CH2, OH. But whereas H2 in the presence of nickel or platinum palladium, they can also reduce that one. CH3, CH2H, that is CH2H and CH2OH. Okay, so this is very, very most important. So in your JEE mains or NEET or KCET also, in your board exams also, whenever they are asking, just remember these all are the strongest reducing agents. Okay, so here you can see the answer here. Okay, yeah, crotonaldehyde, very, very most important, guys. Remember this one. This is called as crotonaldehyde. Crotonaldehyde. Okay, crotonaldehyde or crotyl alcohol formation will be takes place. Right. So Grignard reagent is another important story about Grignard reagent. We'll study about this one in the next class, guys. Thank you so much for joining the class. It's already 3:50. So I'm going to stop the class here. Another 5 minutes is there. If you want to ask any doubts, you can ask. Others, you can leave. Thank you, guys. Thank you for joining the class. Okay. Right. Yeah. So we'll discuss this one in the tomorrow's class. I think no one has much doubts.